Life is not as simple as it seems. It has its own variations. Now, what are isotopes? You know, there are some atoms which have same atomic number but different atomic mass number. What do I mean? That for example, carbon, it exists in two forms. One is C12, other is C14. But in both the cases, the number of protons is 6. So, then why is it 12 and 14? That means in C12, the number of neutron is 6 and in this it is 8. But the number of electron remains same, that is 6. So, which means the valency will also be same. 2 electrons in the first shell, 4 in the second. And carbon has this unique property that it neither gains electrons nor it loses electrons, it does something else, it shares. So, what we find is that carbon can exist in two forms due to different neutron number. And when an element exists in two forms having different atomic mass number but same atomic number, then they are called isotopes. So, because the atomic number is same, which means the number of electron is also same, so their combining capacity is also same. So, what about their chemical properties? Naturally, even they are same. So, an element that exists in two or more forms having same atomic number but different mass number, then they are called isotopes. We see this phenomenon even in chlorine. Now, in the case of chlorine, it exists in two forms of 35 and 37. Now, what is, okay, this is one thing, even hydrogen exists in 3 isotopic forms. One is with atomic number 1, atomic number is always 1. First is protium, in which the atomic mass number is 1, then deuterium, in which it is 2, and then tritium, in which it is 3. So, hydrogen exists in 3 forms, but in all the cases their properties do not change because electron number is same. Okay, that is fine, but if we are given a certain amount of element, how do we know which ones are heavy and which ones are light? In the case of chlorine, what we find is that about 30% are having atomic mass as 37 and 70% are having mass as 35. So, if we go by 75% and 25% phenomenon, then what we find is 35 into 3 by 4 plus 37 into 1 by 4, and then the average will be about 35.5. This is just for understanding, it is a fraction. But what we mean to say is that there are chlorine atoms as with 35 number and also with 37, but 37 are less, and so the average atomic mass of chlorine is 35.5. Whenever we are making calculations, we use the figure 35.5.